beer.
Yeah, chat about beer.
We could definitely do that.
So good to join us again, Ben. So I believe, if I'm correct, that you've arranged a live brewery tour in a few minutes, but not quite now. So we can just take a seat back and get ready for it. We've just had some coffees here in the IMD studio in The Hague at the Hague Humanity Hub. And would you mind telling us a bit about the brewery? What beer are we going to see today?
So that's a very good question. I've got no idea about actually what beers or what we're going to see there, but I know they've got a distillery as well. So it's actually not just beer brewing, it's distilling. And it's the first time we've done something like this live. And I think, it will be very easy to kind of pre-record this, but kind of for better or worse, I think we're going to try it live, and we want to get some interaction from people asking questions to Fergus, who is going to be showing us around his brewery.
Great. I mean, so we have Fergus. He's just popped into the waiting room. So shall I bring him on board? And then we can just talk a bit about the brewery name. So it's Adnams Brewery, I think. Yeah.
In the UK.
And we can ask Fergus when he arrives, but I have many questions about what kind of beers they make. So let's just check. We have Fergus Fitzgerald, our next speaker. And I think soon. Here we go.
Hi,
we
Fergus.
see you, Fergus.
Hello, can you hear me?
We can, loud and clear.
Good. Okay. So I'm Fergus. I'm the production director at Adnams Brewery and Distillery in Southwold, which is on the east coast of England. I am going to be wandering around the brewery and distillery, and there's lots of metal knocking about, which isn't great for mobile signals. So if I do drop out or freeze, just bear with me and I'll be back pretty quickly. So I'm just in our distillery at the moment, which is here. And I'll talk a little bit once we get through about what ends up in the distillery. But as this is the most attractive view in Southwold, not with me in it, obviously, but I thought you might want to see where we are. So
You got a great lighthouse.
it's not bad, is it? There aren't many breweries with a lighthouse, so we're quite proud of that one. So this is the best view in Southwold until you get obviously into the really interesting things which we like to look at. So I'm going to wander down. Actually, what I'll do is I'll take you through the sort of start of the brewing process. So I guess most people know how beer is made in a sort of general sense. And most people are aware that it's turning sugar into alcohol. So it's a mixed strain yeast. So we've got, or for breweries historically, because it was sort of a culture that grew up and sort of acclimatized to your normal brewery, and then it was just transferred from brewery to brewery and grown up. Our yeast was probably 4 or 5 different yeast strains when we had it in the sort of 1970s. The brewery had issues with the consistency of the beer, so they decided to clean the yeast up to turn it into two of the most dominant strains. So 90% of the sort of yeast was actually 2 strains. So they cleaned it up to leave just those 2 strains. And those are the 2 strains we still use today. So we do a lot of work in sort of managing yeast. And once I get through the brewing process, I'm going to hand you over to Connor, who's in our lab, and he's going to talk a little bit about what he does there to try and make sure we manage our yeast strain to keep those 2 yeast strains in balance. But going back to the brewing process. So in here, we've got some barley. So we use malted barley from this region. It's all grown and malted in this region, which is quite an easy thing for us to do, because where we are, it's surrounded by lots of barley, lots of wheat. So actually, there's lots of those malted barley quality or strains grown around here. And then it's also malted in this region. So we use different types of malted barley. Pale ale, which has got a relatively low color. We use some chocolate, which, as you might think, has got a slightly darker color to it. We use things called crystal malt, Munich, Vienna, which are all been malted. The malting process turns that starch, makes that starch more readily accessible to enzymes. So within those barley strains, there's an embryo, there's a starch supply. The malting process is really about getting that grain germination going. So it's making some enzymes, which will then eventually break that starch out to sugar, which is what we're going to feed the yeast actually ferment with. But the sort of process along the way involves drying it, and then they send it to us until we turn it into a mash. Okay, I will do.
Nice.
Right, I'm just going to take you to a screen that sort of shows the brewing process, or a diagram that shows the brewing process a little bit clearly than my sort of waffling on. So this is our sort of description of the brewing process. I don't know if you can see that clearly, but essentially it's showing that malted grain is coming in, it's going through a mill, it's going into what we call a mash tun. So in the mash tun, you have ground up grain and water. We control that mixture to a sort of temperature of somewhere between 64 and 69 degrees Celsius. And what that's doing is it's encouraging different enzymes to work at different rates. So what we really want to do is turn that sugar turn that starch into sugar. But we want to turn the sugar into a mixture of different types of sugar. So we want some complex sugars, we want some simple sugars. The reason we do that is because our yeast strain will use the really simple sugars. It'll use some of the complex sugars, but it'll leave some of the more complex sugars as unfermented sugar in the final beer. So that will give us some sweetness to that final beer. So we don't have to, as you might have to do in other sort of alcoholic drinks like cider, you don't have to sweeten back. You can just use the sugar that you've taken naturally from the grain. So our yeast strains, there are some yeast strains which will ferment some of those really complex sugars right out, so get rid of all that sweetness. But our yeast strain, our two yeast strains, they will leave a little bit of sweetness in there. So that's really where we set the final sweetness, and essentially the alcohol of the beer. So the more we turn those starches into really simple sugars, the more dry the beer, the more alcohol essentially it's going to make from that amount of sugar or amount of starch. If we try and have much higher temperatures, we tend to favor the enzymes that make much more complex sugars, and therefore we end up with a much sweeter beer. So once that mash has been sat in the vessel for about an hour, hour and a half, all the starch has been broken down to sugar by the enzymes. And again, this is enzymes that are just produced by the barley. We're not adding any extraneous enzymes. It's purely what they make. From there, that mash mixture, which sort of looks like watery Weetabix, I'm aware I'm talking to an international audience, so I'm not sure how translatable Weetabix is, but let's go with a normal cereal that's been watered a little bit. So it looks like that sort of consistency. And then from there, it goes into the lauter tun. In the lauter tun, essentially, it's a big sieve. It's got metal plates in the bottom with lots of little holes in it. This mixture of ground up grain and water is pumped on top of those plates, and then the liquid drains through. And that liquid we call wort, and that has all the flavor, all the sugar of the barley. From there, we move it to the kettle, and in the kettle, we boil it. We boil it for about an hour, and during that hour, we add some hops. So here are some, well, I was going to say fresh hops. They were picked about a week ago. They're so people know what hops look like. That's what they look like growing when they're a bit greener, a bit more attractive looking. So we use hops to flavor our beer with, or flavor our wort with. We use it for bitterness, we use it for aroma, and essentially they're a herb that we use to flavor beer with. We use lots of different varieties because all the varieties have different flavors. And then at the end of that boiling process, where we've extracted that bitterness from the hops, where we've extracted those aromas, we then cool it down to about 15, 16 degrees Celsius. And then from here, we put it under the road into our fermenting room. And that's when actually we start getting involved with microbes. Up until this point, all we've been really trying to do is create this sugary liquid to feed to the yeast. So it's really, really the next stage where we start to see the microbes. So I am going to have to start to move. And so if I lose you, bear with me. I won't be long before I get into the fermentation room.
Oh, we have faith you'll come back. Don't worry.
Cool. Yeah, exactly. Yeah.
So I'll walk through the brew house. So the brew house is what we call the bit of kit that essentially helps us extract that sugar from the grain and flavor with some liquid. And it takes about 8 hours per batch through this process. And at the end of that process, we have this sweet sugary liquid that we have flavored with some hops, but it doesn't taste like beer yet. It's very sweet. The pH is relatively high, so we're looking at a pH of about just over 5. All right, so we're now outside. So we have our fermentation room across the road.
Okay, so I think we've lost Fergus for a second, although he's just come back. So here we go. He returns.
The suspense is absolutely killing me. I can't. Where?
Yeah, here we go. We're back in the brewery. Now? Oh, you got to unmute. There we go.
Okay, I was just saying, you can tell it's live.
Yes. We can hear you now. I think we can see you. Gone back.
The stream's good now.
Yeah, so see in there, this is one of our fermentation vessels. So the wort has gone in, which is all that sugary sweetness from the barley with the flavor of the hops as well. That liquid, then we check what we call the gravity, but essentially it's the density of the liquid, which we relate back to how much sugar is in there. Then we use our yeast, our house yeast, for almost everything we ferment, apart from 2 beers, where we buy in some other yeasts. Yeast goes in, and then obviously yeast does its fermentation, and you probably can't see quite well enough, but it is bubbling away a little bit down there. This fermentation is probably about 2-3 days old now. So typically we warm ferment. It's probably enough looking there. So we warm ferment for most of our beers, which means we ferment somewhere between sort of 16 and 23 degrees Celsius. So all these vessels up here, they've all got glycol jackets, so we can control the fermentation. Because our yeast will produce different flavors at different temperatures. Because it's a 2-strain yeast, it's quite flexible. So we can get quite estery flavors coming through. We can get lots of strawberry, lots of banana, lots of pear drop as well at those higher temperatures. So for those beers where we want lots of those fruit esters, we'll ferment a bit warmer to get those flavors. If we want a beer that's a bit cleaner, we'll typically ferment sort of colder, so 16 degrees Celsius with our yeast. It doesn't like to ferment very cold, so unlike lager strains or Saccharomyces cerevisiae or house strain, it likes to ferment a bit warmer, and it will slow down. It won't really ferment anything below 12. Anything less than that, it will sort of stop fermentation. So we sort of use those characteristics of our yeast, our house yeast, to sort of drive the flavor. So really, really fruity if we want it. Well, really high temperatures up to 23 if we want those fruit flavors, and 17, 16 if we want it drier, and less influence from the yeast. So we see every beer is its own recipe, it has its own flavor profile. So what we're looking to do is that every beer has something that is unique to it, and sometimes that's the malt character, sometimes that's the hops. For almost everything we use with our yeast, there is an influence of our yeast in there. It has some flavors in there. And one of our yeast strains produces a small amount of clove, which is unusual for most English yeast strains, but quite common in Germany and Belgium. They have a small amount of that clove characteristic. So we like that in some beers. We don't like it in others, so we play around with the temperature and the ingredients. There's Dan. It's live. So we play around with those temperatures and those characteristics to try and give us different flavors. Lots of people will use a single strain yeast. So a strain, usually lager strains, or sort of a very, very simple strain, which isn't really characterful. And we do use those strains for some beers, but we don't want our influence on those particular beers. But for the vast majority of what we do, we want our house character on it. We want our stamp on it. So I'm going to head back across the road. Hopefully I don't lose you this time. So bear with me.
I've still got you.
I'm going to take you to our yeast room. So we do some public tours, and all this is on the public tour, really, except when the CO2 alarm's going off, which they're not at the moment, which is good. But the place I'm going to take you to next is our yeast room, which I guess is pretty appropriate, but it's somewhere we don't take people normally. It's in the back of the brewery, sort of hidden away. But that's where we store our yeast and grow up our yeast for the next batch of fermentation. So you'll have to bear with me while I wander back.
You got a nice day though. Beautiful blue sky.
It's not bad. There's the lighthouse again.
Ah, lovely.
So one thing I haven't mentioned so far about our yeast is we call it a top fermenting yeast. So breweries typically split yeast. Sometimes people use top fermenting, but they bottom crop it. So essentially what cropping means is where you take the yeast off. So when we put the yeast in, as well as fermenting and making alcohol, it's also growing into more yeast. So typically we'll get 3 times as much yeast out as we put in. So with our yeast, because it's what we call a top fermented yeast, once it's finished fermenting the easy sugars, it likes to rise to the top of the vessel. and then we skim it off, which basically involves lowering a funnel down into the beer and vacuum that extra yeast off. And then from there, it goes back into our into our yeast room, where we store it at about 4 degrees Celsius until we want to pitch it into the next vessel. So we're essentially self-sufficient in yeast. Yeah. So this is our yeast room. So we've got some storage vessels here. So that's a storage vessel with some liquid yeast in it. So our yeast would be about 15% solid. The rest of it's made up of a mixture of beer and gas. Because obviously, as well as the fermentation, making sure it's also making lots of CO2. So that forms a lot of the slurry. So we'll store the yeast in here for maybe 2 days. We don't tend to like to store it much longer than that. And then within those 2 days, we'll usually have used it. So we'll weigh it into our weighing vessel. We'll have worked out the percentage solid in there. So we'll also do a viability test on it to see how much live yeast is in there. And that tells us why a very, very interesting calculation that no one seems to understand how it works. But that's roughly how much we need to weigh to put into that weighing vessel. And then, because it depends on the viability of the yeast itself, which is always changing how happy the yeast is, how healthy the yeast is. So we have a little centrifuge here, just helps us to spin down the slurry into its solid component, its gas component. The stain, so we use a methylene blue stain. You can use a violet stain, which is probably a little bit more accurate, but we use methylene blue because we find it is accurate for what we want to do. And that will tell us whether there's any dead yeast in there or yeast that isn't particularly healthy. Because the cell walls of those yeast strains would have broken down enough to let the stain in. So we'll do a count under a hematometer, just looking at it to see what percentage of cells have absorbed the stain, and that tells us roughly what health the yeast is in. So.
Nice, Fergus. I was going to ask you in there, like how many times can you reuse the yeast? Is it at some point you have to kind of start again, or is it just perpetual? Like you skim it off, you store it, and then you can put it back in as many times as you like.
So we run it probably for about 20 generations or so. So every cropping is one generation. It's complicated a bit because of this 2-strain yeast we got. One strain is what we call very flocculent, and one strain is not flocculent at all. And in combination, when they're roughly in balance, the flocculent one will pull out the non-flocculent one. Unfortunately, every generation, the non-flocculent one grows in percentage. So to try and keep on top of that, we used to wait till it got bad and then fix it. We decided we'd try and get ahead of it a little bit more. So we do a continuous culture of the flocculent one. So we're always growing. So we'll have, say, 7 hectoliters worth of the non-flocculent strain growing all the time. We'll pitch 3/4 of that into the next brew to keep the balance in place. And then we'll add some more fresh wort into that to grow that yeast up again. So we're always growing the strain that is dropping out all the time to keep us in balance. But we do then go back to the original strains, sort of between every, let's say 20 generations, we'll go back to the original strains again and grow that up from scratch. So we'll take it, we've got a yeast bank that holds our 2 yeast strains so they hold our yeast strains, they'll send it up to us, and they will grow it up from that up to a big enough size, which is probably something Connor might like to talk about. I'm just going to go and interrupt him, and he can talk about, I think that's probably a good place to cut in actually. So Connor will talk a little bit about how we take our yeast strain from those little vials coming up to commercial pitching.
Sounds good. Yeah.
Welcome, Connor.
Hello.
Hi, Connor.
Work.
Yes, it's working. Thank you. Okay, so I guess I will grab a slope for you to show you. To the lab. So if we were ever propping up, I've got laminar flow here, so we'll always do it in there. But these are the slopes. So we we streak these up ourselves from the stored culture we get from Camden BRI. I don't know if you can. This is. I don't know if you can see the yeast on there, but we'll take a small amount of zinc sulfate, which is 0.2 ppm, and we'll wash the slope off, and then that's washed off into a 250 ml conical, and then put on a shaker. It's into 100 mil, of wort as well. That shakes for 2 days, and then they get pitched into 1 litre of wort, just in slightly larger conical. And then that's just the simple part, but then we go up to the bigger vessel, which I have here. Hopefully you can see. So this is what we like to call R2D2.
It does look like a robot.
It's a 25 litre. Well, it's actually, I think it was an old milk churn, wasn't it, Fergus?
Historically, it's a milk churn.
Yeah, it's a milk churn. It has been
Adapted for beer use.
Yes. So from the shaker, which is over here, when we take off our propagations, they go into there, and then that goes down into the yeast room. I don't know if Fergus showed you.
I did.
We saw a fermentation vessel.
And basically, that sits in for another couple of days. So obviously, the propagation has to work that way because of the cells just don't increase. They get to a certain point after a couple of days, and then for quorum sensing or whatever other reasons, we don't end up with any more cells. So that gets to about 25 litre stage, and then that goes into one of the bigger vessels you would have seen down there. We push in sterile oxygen, and to push it into those big vessels. And then that goes up to the how many litres is it? We say YPV.
So it's 4.5 barrels. Let's say 7 hectoliters.
So it's about 700 litres.
Wow, that's a lot of beer on the way.
Pitching with 700 litres of yeast.
Well, it was 700 litres. I pitch into 700 litres of wort, then sits for a couple of days, and then we should end up with about, I think at the moment we're trending about 20 kilos of yeast when we centrifuge out. That then goes to top up because of our dual culture. So that tops up the balance basically, and then we pitch in probably what would you say we pitch in normally? Kilos.
Kilos. So we're about 150 kilos.
Yeah, so 150 kilos or around there
of just raw yeast
into each fermentation. Yep.
Yeah.
Of each fermentation. So
and you've got
we'll probably end up getting about 3 times that amount off when we skim it off as well.
And that's the thing, you said you had top fermenting yeast, so it floats at the top of the fermentation chamber.
Yes. So that's
in that area. Yeah.
That's where we do what we call skimming. So then at the right time, it's skimmed off, and then it's funneled back into those vessels. So.
And is that the same?
That for the next brew.
Okay. Is that the same kind of yeast? So I know there's top fermenting and bottom fermenting yeasts.
Yeah.
Is top fermenting, which is the one that, so lager is one and ale is the other, I remember being told at some point, or was it a bit more complicated than that?
Yeah, it's a bit more complicated than that, but traditionally bottom fermenting is lager and top fermenting is ale, but really you can do either.
Okay. Nowadays it's a bit more complicated. Okay. But so this would be, your yeast is perhaps more like a traditional ale strain than a traditional lager strain.
Yeah,
or again,
definitely.
Yeah, okay.
And I'd say ours is actually more familiar. I would guess it's more like a Belgian ale yeast.
Yeah, okay. I mean, we're here in the Netherlands, so we get a lot of those Belgian beers.
The profile we have on it, it's definitely more. It's not very traditional British, I would say, but that's why we like it.
Yeah, absolutely. And so I mean, nowadays you can go into things like ester profiles. Does that really inform the way that you make, the flavors of the beers that you're brewing? Is it very central to how you're thinking about the outcome of the beers?
It definitely is for us. For certain beers, we really want certain esters. So I guess I'm new on Cobalt. we're really relying on our yeast singing, basically, because there's not much else that goes into it. So the idea is that you can really taste what our yeast tastes like in that beer, and it's really banana-y, and it might have a bit of clove on it as well, which is, again, it's more like a Belgian ale strain. You wouldn't usually create a lager with that either, but we do.
Okay, so you're mixing it up a little bit. And what's the kind of highest strength in terms of alcohol percentage that you get to in your brewery? And does it start to kill your yeasts off, or do you not get that high? Because here they do about 12% sometimes when you get a triple or a quadruple beer.
Yeah, so I mean, we do both barrels, which are barrel aged beer that is bottled broadside, but then, you know, with a bit of extra, some cherries in it and other stuff. But it's barrel aged for, I don't know, how long are we barrel aging that now for? Depends. A year, but then it's blended, so it's. But that can get up. Some of those casks, some of them will get up to 11, maybe. I don't know. The highest one we've had is probably around 11. Some others are only do 8. But I think our yeast tends to sort of tails off at about 11 at the moment.
Okay, gets a bit unhappy, a bit too drunk, and has to slow down.
Yeah, it really does struggle at that height, but up to 8 or 9, it will go very quickly.
Yeah,
Especially
okay.
one of our, because it's dual strain, class 1 strain, is it ferment. It's really fermentable. I think the attenuation is over 90% easily, and the other one's a bit lower. So when the balance goes out, the fermentation actually changes. So our final gravities will change depending on the balance of the yeast.
And do you have to? Yeah, I was going to say, do you have to be quite protective of your yeast strains? Are they your top secret strains, and do you have to, like, you know, make sure no other breweries get hold of them? Are you proud of special strains you've developed? Anything secret, or you know?
I wouldn't say ours is really a secret, because it's also a bit of a pain to work with, so no one else would want to work with it. So we don't have to worry about that. But obviously we do have it stored in multiple places, so obviously we don't want to lose it. That's the main thing for us. I don't think it's too dissimilar to probably some other strains, but the fact that we have this dual strain, that's what's really unique about it.
So what makes it so difficult to work with? Is it just the conditions, or does it have some weird characteristics that cause you difficulty?
Yeah, because it's 2 strains, and one of them is more flocculent than the other, and also one seems to skim better. It means as we go on, so as we go through more generations, it will tend towards class 1 rather than class 3. Class 1, the class is just. That just means class 1 means it's non-flocculent, basically, and class 3 is fairly flocculent.
So what does this flocculent word mean for someone who's uninitiated?
Yeah. Basically, it means that the cells clump together. So they'll produce on the cell surface membrane, and then they'll clump together. Obviously, and there'll be co-flocculation with the 2 classes as well, even though class 1 is non-flocculent. But that's the main reason why it's really difficult to work with, and because they're quite different, it'll also cause issues in the brew house. So we'll have the fermentation changes, so the PG will go down. One's better at clearing diacetyl as well, class 1 is, but then we can't get the yeast counts down, which is really important for cask cracking. So we're always trying to keep it in balance, even though it's constantly going out. That's why we do those top-ups every 2 weeks. We're constantly having to top it up just to try and keep it in balance, because when it is in balance, that's when it's at its best.
Okay, so you are dedicated to this strain of yeast, and you've never thought about replacing it with something a bit easier? Is it the flavors you get from it?
I think we've thought about it, definitely. But we're used to it.
Yeah, fair enough.
It just works.
Yeah, it's like your own child, really. You just get used to it.
I mean, if we could find a strain that gave us everything we wanted, then maybe, but I don't know.
Well, maybe it's the price.
Some other strains at other times, and special breweries will use some dried yeast of other things just to change it up a bit.
Okay. And so how many different strains have you said you used 2 in this kind of fermentation process, but how many different strains do you keep track of across the brewery?
really only those two. The others will all take in as dried yeast, so they'll just be for a special brew. So
okay, yeah.
One-offs or...
So you've got 2 main yeasts for your main brew, and then a couple of special yeasts for the one-off batch brewing. Okay.
It's interesting. Like when you take in another yeast, like how do you choose another yeast to kind of put in? Is it because you know it gives you very specific properties for a new type of beer, or do you have to kind of really understand all of the different kind of esters and aromatic compounds it's producing to add to the flavor? Is it a very complex process to kind of bring another yeast into the mix?
Well, luckily we have some quite experienced brewers here, so it's mainly the profile. So certain yeast we'd use for certain styles. So if Fergus wants for us to brew a specific style, then we'll know that there's a short list of yeasts that we might use from whoever we can get them from. So yeah, that was a good one we did recently. So, and that created quite a low pH as well. So that's it. It's just basic. It's generally on styles, and we'll pick them. And we've used what else we use? I guess we use some saison yeast.
So we use the saison, we use the Larry yeast, Quebec yeast. We have used. So we use a specific Kolsch yeast. We use a wheat beer.
Yeah, Kolsch and wheat beer as well. Those yeasts, but really, we'll just check the profiles and then we go for it. When it's a special brew, there's not we don't have to worry so much about it. It's sort of a test in its own, and because we know we use trusted yeast strains that other people use, so we know that they're going to do the job that we want them to do.
Excellent. So where are we in the beer brewing process now then? Do you have any next steps for us?
That might be back to Fergus if we're on to the next brewing step.
Okay. Cool. Right.
But yeah, give our thanks to Connor.
Thank you, Connor. Thanks.
Thank you.
All right. So kind of talked about whether you want to know about some of the other microbiology work he does. Because obviously yeast is very important to us, but we do have other spoilage bacteria, other things that we're interested in testing. So if you wanted to look into that, if you've got time, then Connor can talk to that as well.
Oh yeah, I mean, yeah, definitely interested in that.
Yeah, I'm going to pass you back to Connor then. And you can finish his bit. Yeah. There you go. Do you want any plates or anything?
No, it's all right. Yeah. All right. Okay. Yeah. So, yeah, I guess not in line, but it's all in the same range for me at least. Anyway. So we plate up. I mean, a beer almost every stage now, from yeast right through to the final pack. What we're mainly looking for is Acetobacter, lactic acid bacteria, or any wild yeasts. So wild yeast, which we might also be interested in both barrels. So like Brettanomyces, for example, we don't want that in the majority of our beers, well, basically all of them, apart from we might want a couple barrels of both barrels to have some Brett in them, so they can produce some more interesting aromas, so they can produce some really fruity esters. Also the barnyardy and sometimes a bit funky, but when you're doing something for blending, that can be really handy. But generally, they would be spoilage, or termed as spoilage microorganisms. The others are also, can also be used. So Acetobacter, for example, would also be used in both barrels. So Acetobacters, it will produce vinegar basically from beer. But if you don't have too much, you'll just get a nice acidity. So I think probably the best example is probably Rodenbach. Is quite strong in acetic acid. It also has lactic acid bacteria. So that will yeah.
So if you get some kind of spoils, like because the kind of acetic acid, lactic acid bacteria, like I think of my home brew now, it's like destroys it, and you can never like brew in the same bucket again because you've got this bacterial contamination. But are you saying like because you're plating it up and you can see it, is there any way of kind of controlling it as you're brewing to adjust the flavor profile so it actually doesn't ruin a batch, or is it? you know?
Generally, we keep a close eye on things, but for most, it doesn't affect it. So I'll see if there is a certain amount of acetobacter, for example, creeping into maybe cask beer. And if it gets too high, then we might have issues, but generally we won't. And especially for keg, you don't really have to worry about acetobacter. Even if it ended up in there, then it's a very low dissolved oxygen environment, so it's not going to survive. It's not going to spoil because it needs that oxygen to produce acetic acid. Same with lactic acid bacteria. Really, like if it's in low amounts, and it also depends what lactic acid bacteria you have, because it turns out we had one and it doesn't spoil very well. We found it, but we even tried to force the beers to make it spoil, and it wouldn't. So it was there. It's sort of pretty much cleared up now anyway, because we've changed cleaning regimes because of that, and many other things around that. So it's a bit more complicated than just, oh, we've got acetobacter, that's bad, or we've got lactic acid bacteria, that's bad, because sometimes, even though they're technically a beer spoiler, they might not actually be spoiling your beer.
I didn't know you had a homebrew, Ben, but I'm not surprised.
This is my kind of like ulterior motive behind kind of coming on this tour. I want to kind of get some tips and
you're here to glean insights for your own beer.
Yeah, I need to get like a little robot. I think I don't have one of those, so maybe I should get one of those. And also 20 kilos of yeast. I use a lot less than that. So
okay. And is yours top or bottom fermenting?
I use different ones. Normally every batch I kind of get a different yeast, so it depends what style I make. But yeah, I think the last one was a top fermenting one as well.
Okay. I know how much is in a keg or a barrel for you in comparison to? So you don't have 700 kilograms. You have perhaps a few liters.
So I think the most common one is like 20 liters, but I actually make 10 because I had a few bad experiences in university where I made such a mess of the beer, and like throwing 20 liters of beer away is quite painful. So 10 liters is it's not very much, but it's enough to kind of test it out and play around with different things.
Very nice. And what's the outcome? What kind of beer do you get at the end? Is it anything like Adnams, or is it more like a lager, or what are you aiming for at the moment?
Sometimes I haven't done it for a while, actually. So I'm definitely inspired now to kind of do some more, but it just, I've got this little book and it's kind of got lots of recipes. So normally I'll try and do something a little bit unusual, something I haven't tried before. Although the last one I think was like a saison or something like that. But yeah, either something like kind of different or something that I think would just be a nice beer that you can kind of produce regularly. But I haven't been able to do that yet. There's always something different. I guess I don't control my conditions well enough.
And you don't have a laminar flow hood?
No, I don't.
Oh, alas. I noticed you've got some a nice rare pipettes behind you. Now, is this for testing your yeasts?
Well, yeah, that's just generally for plating up. So
yeah, okay.
So yeah, I guess with plating our yeast, so checking our yeast culture specifically, I would check that for wild yeast. So what I use is YMCU, so it's yeast and mold agar, but with copper sulfite added, which our yeast does not like. So our yeast won't grow on that, but wild yeast like Brettanomyces should. So generally, I will just do spread plates for that. I do those now almost every day. We would take samples every day just to check that we're not, because that's the most important part, is that if your yeast is contaminated, then you're going to contaminate everything else down the line. So you've got to make sure that's good before you start trying to concentrate on everything else.
And what kind of contaminants do you get? Is it just other molds or other fungi, or can it be bacteria, or like you're never sure?
Yeah, you can get bacteria in your yeast, generally anaerobic, just because of the conditions they're stored in. But so generally it would be lactic acid bacteria, which we do occasional testing for. It's hard. There's a lot of the microbiology in brewing is very difficult because beer's fizzy and it's full of yeast or solid parts. So certain things don't work quite as they should. So we have to have some sort of adaptive methods. We can't sometimes plate as much as I'd like. So I can only do 0.1 mil on a spread plate for YMCU. I'd like to do more. I'd like to be able to be more sensitive than that, but because the yeast slurry is so thick, that's just the way it is. There's not really much else we can do apart from trying to force something and then just being a detection test.
Yeah. Wow. So I'm just looking at the time. Are we doing anything else in the lab, or do we have to kind of get a move on? I'm not sure.
I think now you'll move on to Fergus. Yeah.
Thank you, Connor. Thanks very much for that. It was really interesting.
Right. I'm just going to take you now to show you the rest of the brewery. So we've sort of seen where we make the works. We've seen the initial fermenters. So I'm now going to show you where we finish off the beer and then where we package it. So having had a very stable connection for quite a few minutes, I'm probably going to ruin that.
Right on cue.
We're
ready for it. We'll re-establish the stream.
Good.
We have a vineyard tour
so,
in Australia coming up. I wonder how the connection will be at that point.
Oh, the connection here will definitely be worse. Absolutely. No
okay.
Right. So I guess one of the things I didn't say at the start. So Adnams has been here since 1872, but the brewery has been on this site since 1616. It passed through a series of hands until the Adnams brothers bought it. But Southwold itself is quite a sort of tourist town now. So we have a very limited amount of space. Basically, everything's built up around us. So we sort of squeezed everything in that we possibly could. So these are our conical, we call them dual-purpose fermenters. So they're dual-purpose vessels. So they can be used for fermentation. The fermenters I showed you earlier were flat-bottomed because we're not trying to take any yeast off the bottom of those. Our yeast likes to rise to the top, so we skim that off the top. There will be some yeast that drops to the bottom, but it drops at the sort of base level, and we have a standpipe in there which allows us to draw the beer off above that. These vessels have got a cone on the bottom, and if we're fermenting in there, typically you'd ferment with a lager strain yeast in there, or a bottom fermenting yeast, so that the yeast drops into the cone, and then we have chilling in the cone to sort of make sure we maintain that yeast and keep it from going off, and then we can take the yeast off. Conical fermenters are much easier to work with, much easier to clean, much easier to automate, but our yeast doesn't like them. So our yeast determines what we do. And I think you probably asked, Connor, have we looked at moving away from our yeast strain? And we absolutely have. But there's a bit of romance to it, I guess. It's a bit of heritage. It's been with Adnams longer than anyone else here has been. And it is part of the workforce. It is part of the character of most of the beers that we make. And we have dabbled in the past about whether we could get a single strain yeast, because actually that would be much easier to work with. You make one change, the yeast reacts in one way, whereas you've got a dual strain, you make one change and you get at least two different reactions, which you then have to try and balance. So one single strain yeast are much easier to work with, but they're not as flexible as our yeast strain is in terms of the range of flavors we can get from it. But the primary reason is we like it. We like the uncle in the corner who's a bit moany, but actually he's got some good stories, and he adds some colour to the party when the family get together. So we like that. So we have resigned ourselves that our yeast will always be here, and we will always have to find ways to work with it. So what we mostly use these vessels for, although we do ferment some lager in them, most of the time we use them as conditioning vessels, which means beer that's been in the open fermenters where we saw earlier. Once the yeast has dropped out of that, once we skim the extra yeast off, we'll send the beer from there into one of these vessels. We'll then chill it down, and that helps more of the proteins to come out. So that helps it get ready for filtration. And then from there, it'll go through the filter. It'll go into a bright beer tank, which is a tank that holds beer that's been filtered. And then from there, it'll go to kegging, or it'll go away for bottling or canning. But actually, most of what Adnams has done in its history is really around cask beer. And cask beer is beer that hasn't been filtered. So instead of coming into one of these vessels, once the yeast has dropped out enough in the open fermenters, and we want to get down to a place where the yeast count in there is about 1 million cells per mil. Once it's in that level, then we'll bring it back here and we'll put it into a buffer tank, and then from there we'll put it into casks. And so we won't filter it out. I guess it's as close to drinking beer straight out of a fermenter as you can possibly get. And that's what these look like. So these casks here, these come back from our pubs. We'll clean them, we'll put it through a washer, and then we'll put this beer in that still has live yeast in it. And we want there to be live yeast in it because the yeast is then going to generate, well, we call it conditioning, but essentially what it's going to do is do a small amount more fermentation. It's going to create a very small amount of alcohol, but mostly it's creating some more CO2 to carbonate the beer while it's in the cask. And that's why these tubs are shaped the way they are. So they've got a belly on them, basically. So when it goes into the pub, it sits on its side like that. So the belly is at bottom. The tap goes in there. And then you leave it settle. So you put it up, you let it vent, you let the excess CO2 that it's built up over, say, maybe 2 weeks since you first filled it. You let the excess CO2 go. That allows the yeast to sediment properly. Then you hard peg it, which means you make sure you retain all the extra CO2 that's going to be built up from there on in. Our yeast does make some sulfur as well, so there is a bit of sulfur dioxide. So some of that initial venting is about letting some of that extra sulfur dioxide go. So it does generate a bit of natural preservative. We let it settle then for usually 2 days, and then the bright beer, after the yeast has dropped into the bottom of or into the belly of the cask, that bright beer is then drawn off, and that's what we serve in the pub. So I think England is probably one of the very few countries in the world who are serving beer in that way. And cask beer is what we call it, but that's sort of been the primary bit of what Adnams has done over its sort of 149-year history. So this is then the final bit of the processing. So that's a filter. The centrifuge in the Dan there. That's a Dan. And these are our filling heads. So along here, you can see there. So this is our filling. So we're not filling at the moment, but essentially casks will come up along this conveyor. That conveyor come up here, and the brewing team, the racking team, will take the casks, lower them down here, and then the head will drop in. And that head is basically feeding beer from that very first tank that we saw. That's been pushed into a buffer tank and then fed into here. Because it still has yeast in it, if you serve it that way, unless you can let it settle for maybe a month, you will have some yeast still in suspension. That will make it look cloudy. And historically, cask beer has always been served bright. So the way to get it bright is to add some finings. Historically, that finings has been a fish protein that attracts to the yeast. The yeast then clump together, become heavy, and drop down. You can use some other vegetarian finings now, but that isinglass finings is by far the one that is still used the most because it's the most repeatable. Because for a fining, what you want is something that you want this charge which will make the yeast stick together, and then when the cask gets rolled up to the warehouse, it breaks those bonds, and you need a finings that reattaches those bonds again, and then it gets taken from the warehouse and put it on a dray, and those bonds get broken again. So you need sort of finings that repeatedly has that with the yeast, and isinglass is still the one that sort of probably primarily works the most. I think that is the tool. I think Connor did also talk a little bit about both barrels, which is our sort of barrel aged beer. What Connor didn't mention is we treat it like a Solera sort of system. So when we put a distillery in 2010, so we had some whiskey barrels that we brought in to sort of age some whiskey in. We thought we'd age some beer in them as well. So we filled one barrel with our bottle broadside with some cherries, and then we left it for about a year. We didn't add any extra yeast to it, but what we tried to do was get some wild yeasts growing from the cherries that we added, and we also wanted a bit of wild culture in there, something that we didn't really know what it was going to be. So we got that a little bit from the wood, because obviously the microbes can live within the sort of porosity of the wood, really. So that one barrel, that was back in 2010 we filled it. But then one barrel, we used to take little bits out. We would take it to beer festivals. Whenever we took a bit out, we'd always top it up with some fresh beer. And over probably 5 or 6 years, we constantly did that, but we still only had the one barrel, and we just kept topping it up, leaving it, topping it up, leaving it. And then about 4 years ago, we decided actually this beer was too good just to take to beer festivals. So then we took the beer that was in there, which we called the mother beer, and then we spread that across 10 whiskey barrels. We'd washed the whiskey barrels out a bit because obviously the alcohol will kill too much of the sort of wild yeast and bacteria there. So we wanted a little bit of whiskey flavor in there. But then those 10 barrels were then left for a year. And then that was our first bottling of that. And again, we never empty those barrels. All those barrels are always left with something in them, unless they go off. So if we haven't been very careful about making sure there's not too much oxygen in there when it's fermenting, or other things, other wild yeasts get in that we're not particularly keen on. If they're particularly phenolic, then we don't really want those in there. We want it to be more acid-led, more fruit-led. But the barrels we keep, we will always leave some in there. So we always constantly top it up, and then age it and top it up and age it. And that's how that beer sort of keeps getting made now.
Oh. How big are the barrels?
So the wine, usually, they're either wine or whiskey barrels. So they're usually about 220 litres each. So they're not big. It's a very small batch beer for us, but it's an interesting beer. It keeps Connor interested. So he likes looking to see what wild yeasts he can find under there, and and then growing them up to see whether they give us that fruit characteristic. So particularly Brettanomyces, you can get some Brettanomyces which initially are very farmyardy, give you lots of horse manure flavors, which is not an overly attractive flavor for most people. But actually over time, some of those funky flavors can turn into some wonderful fruit flavors as well. So you can end up with pineapple and mango and peach. And usually for beer, we're getting those flavors from the hops. But actually, with the right yeasts and the right conditions, you can get lots of fruit characteristic from those wild yeasts as well.
Amazing. Useful little organisms.
Yeah.
And that is why we're here, obviously, today, is to celebrate International Microorganism Day, which is technically tomorrow for us, but I've just realized in Japan, it's now nearing 1 a.m. on the 17th. So in Japan, if you're watching, it has just begun International Microorganism Day. And we will catch up with them in a few hours, 6 more hours to go for us. Yeah.
Nice. Yeah.
You're going to be visiting a sake brewery later on as well?
Yeah, so our Japanese ambassador, Ken Ushida, has filmed, I think this one's a pre-recorded tour, but he's gone to a sake brewery.
Oh, pre-recorded chickens.
Yeah, I know.
What are you doing?
But he has made us a lovely video of the sake brewery. And it is a brewery, because I always thought sake was maybe distilled because it gets quite strong. But no, it is brewed up to about 20%, which is amazing. Yeah, it's a very strong brewed drink. But we'll find out more about that tomorrow at... When is the time? For the UK, that will be at 8 a.m., 9 a.m. for us in Europe. And then we also have a Vineyard Tour, which Ben will be doing with a vineyard in Australia at 6:30 a.m., 5:30 a.m. if you want to wake up in the UK. But midnight in America and 10 a.m. in India and 1:30 in the afternoon in Japan. So we're hitting all of a good number of alcoholic beverages across the course of today and tomorrow. Yeah. But best to start with beer, I think, as the fundamental.
It's a good time for beer now. I don't think I'll be up for wine or sake tomorrow morning. I think.
Yeah, sake for breakfast and wine at 4 a.m. Yeah,
that seems reasonable.
Yeah, 6 o'clock. That's perfect time for beer. But yeah, I mean,
I had a question a little bit about the barrels there, and I was wondering because they must, like, the flavor profiles must be very very complex. Does it change over time, like with the taking out and topping up, and kind of, I suppose, the beer kind of maturing and maybe the barrel changing as well?
It definitely does. Obviously, even if you ignore the sort of microbiology of it, just the tannins of the wood decrease over time. I think one of the interesting things about wood, you get this micro aeration, so it's never fully anaerobic. There's always a little bit of oxygen coming in, so that does change how some of the microbes would normally work. So it's absolutely different, sort of storing something in a wooden barrel as opposed to a stainless steel one. It is, you will see differences that you would never see in stainless steel. Anyway.
So apologies. Oh, here we go. Here's some beer.
Very nice.
I thought I might as well finish off with a beer.
Yeah, I got to see the final product. I was going to say, apologies if I missed this, but what does your distillery produce again? Is it whiskey or like a?
So it's primarily gin.
Gin, yeah.
But we make gin from scratch. So most people who make gin, certainly in the UK, they buy in neutral grain spirit that's been essentially distilled already and taken up to a purity over sort of 96, 97%. And then people make gin from that. So we make it, so it goes through the same process, the same brew house, the same fermentation room. We use our own house yeast. We get that to about 7%. Then we send it back to the distillery, who then turn that into vodka. And then we take that vodka and we put it into the gin still with the botanicals, and hey presto, gin.
Cool. Does
we do some whiskey as well.
Sorry, because we talked a lot about the flavour profiles of the yeast and how it affects the beer. Does it also affect the gin?
Yes, I think obviously in much smaller ways, because you're particularly with gin, you're taking it up to over 96% purity when you're making the vodka element. So you've only got a very small amount of stuff that isn't ethanol in there. But you do find that our gin or whiskey has a different profile to gins or whiskies that are made much simpler. And there is a trade-off, I guess, because I think Conor mentioned our yeast strain is not very alcohol tolerant, and you'll all be aware that ethanol may be considered toxic in some environments, but it starts to kill off the yeast once it gets too high. So you can find distilling yeast that will get up to 15-20% ethanol, whereas our yeast, particularly on the washes that we make for the distillery, will top out about 7-8%. So there is a compromise that you don't quite get the efficiency you do with some of those other distilling strains.
And how is your whiskey? You said you made a small amount of whiskey. I mean, is it just a few batches for staff members, or do you sell it on?
It's a small amount. It's a few. It's more than a small amount, I guess. I think the sales team would quibble at with the term small. In comparison to everything else, it's a very small bit of what we do. But we started making whiskey in 2010 in the UK, and I think the rest of Europe. It's got to be aged for 3 years before you can even call it whiskey. So it's got to be aged in oak for 3 years. So we have been selling whiskey for a few years now, but it's sort of building up, and English distilleries making whiskey is a pretty new thing as well. It was frowned upon. It was, and people scoffed a little bit when English distilleries started making whiskey, because that was meant to be Scotland. Only the Scotch or Irish could make whiskey, but I think everyone accepts that's no longer true, and actually good whiskey can come from anywhere.
And is it called Adnams whiskey, or do you have a different name for that brand?
So we call the distillery Copperhouse Distillery, because that was where the old brew house for the brewery used to be. But we put a new brew house in 2007, and so that space became redundant. And then our chairman, Jonathan Adnams, decided we should put a distillery in. And then he started growing some rye. So now we use his rye to make a rye whiskey. So yeah, it's it's all quite local and quite an intimate relationship.
Yeah, that's nice, with the local land and the local produce.
And weirdly enough, the place that Jonathan grows the rye is a place called Raiden, which is just the next village outside of South, where the brewery is based. And Raiden historically means rye on the hill, which we only all found out after we started making rye whiskey.
So it's back to its original usage almost. Yeah. So the beer you're just finishing up with, is that a normal pint of Adnams, or is that a special batch?
This is our New England IPA.
Nice.
So this does use our yeast now. We did play around with using some other yeast strains, but actually the New England strains that other people use are typically all English strains originally. So I think the principal part about it is you get lots of interaction with the hops. So you do get changes. So the hops can use some of the flavors the yeast can use some of the flavors that the hop produces, and do this thing that we call biotransformation, which is quite popular, I think, amongst breweries at the moment. The idea that you can actually put a hop in, and actually the yeast will change those hops into different flavor compounds. So you might start off with being quite citrus, but that biotransformation will turn it into quite pineapple-y, quite mango sort of flavors.
Amazing.
Awesome. I was going to say, we have to thank you for your wonderful brewery tour, because we have some speakers coming in for our next session as we come to the end of the hour. But it's been amazing to see a live tour of a brewery, seeing all of the distillery.
You'll never do it again.
But we have it recorded, so anyone else who missed it can watch it again, and we can send you the recording as well. It will be edited, so we'll cut out those bits where we're in transition. But it's been so good to see the inside of the brewery, all the different casks and fermentation tanks, and the final product as well. So thanks so much, Fergus, and send our congratulations and thanks to Conor for helping
Yeah.
you complete this tour. It was a bit of experimental idea, but I think it went pretty well, to be honest. So thank you.
Yeah, thank you. Thank you very much.
It's been a pleasure. Always happy to support the microorganisms.
Yeah, absolutely.
Yes.
And I hope you all celebrate tomorrow on Friday, International Microorganism Day, and get down to the pub and spread the word to as many people as you can while giving out its beautiful products to everyone around you.
Best of luck.
Right. We'll let you sign
Thanks,
off.
Luke.
Thanks so much. Have a wonderful evening.